In this assessment, you're asked to predict the product of a Grignard reagent, two equivalents, with an ester. And guess what? You're getting bonus coverage because I'm doing part A and part B together in this one. First of all, let's start with just the first question of when we add the Grignard reagent to the ester. I'm not going to draw the mechanism here, but when that first equivalent adds, we're going to make the tetrahedral intermediate. That tetrahedral intermediate is going to collapse to give us this ketone, at least initially. That's going to be the product of that first step. So again, the Grignard attacks the carbon of the carbonyl, pushes the electron pair up, they collapse down, kick out the good leaving group. Let's draw what that good leaving group was, because that's going to be relevant to the second part of this question. Now we use two equivalents, so this is going to continue reacting. Another molecule of the Grignard reagent will actually show this step. So we can draw our Grignard reagent as if it is ionic. The nucleophile attacks the ketone, donates its pair of electrons to the carbon, and pushes the pi electrons onto oxygen. Again, we don't call this a tetrahedral intermediate because it can't do anything else. It just sits there until we do our acid quench. And so when we do that acid quench, our product of this step is a tertiary alcohol, which is only one part of this question. And we don't have part B drawn on the screen, but let me modify this reaction so that it becomes part B. And here's what I'm going to do. Note that when the nucleophile attacked at first and produced this as the leaving group, so we're reacting an ester, and this was our leaving group, what if instead of actually drawing the molecule, we just imagined it as R, where R could be any alkyl group? Right? And so now we've kind of changed our general reaction to any ester with OR that reacts with two equivalents of a Grignard reagent will always make, we'll use R prime to say that was our Grignard reagent, will always make a tertiary alcohol as the product. The series working question A and question B, you should have ended up with the same product. Why? Because it doesn't matter what your alcohol group or what your alkoxy group is. This R group is meaningless. And so the idea here, this kind of represents the idea, we said before that transesterification was difficult, but often it's unnecessary because any reaction that one ester can do, another ester is probably going to do in a similar way. And so that's what this assessment teaches us. Yes, we can predict the product, we make a tertiary alcohol. But it didn't really matter what our alkyl group was attached to this oxygen. We get the same product regardless.